Okay, welcome to Knowledge Share channel. In this video, we will be discussing about introduction to what is binary adder and what are its types. You know that binary adder, there are two different types of binary adder. One is called as half adder, the other one is called as full adder. And how it works, what are its truth tables, and how we arrive at that particular circuit. So this is the final outcome of the your half adder circuit. So we will be discussing in detail about the half adder circuit, and in the forthcoming video, that is in the next video, we will be discussing about the full adder circuit. So this is the final conclusion of what is a half adder. Okay, so what is half adder actually? So half adder is nothing but if you want to add two different binary numbers, okay, binary numbers. For example, A and B are the two different inputs, and S and C are the two different outputs. So S is called as the sum, and C is called as the carry. Okay. So as you all know that we can give either A can be 0 and B can be 0, A can be 0 and B can be 1. So the input can be 0, 0, 0, 1, 1, 0 and 1, 1. So how it behaves, okay. So this is what, so we need to get the answer, okay. So for example, if we want to add two binary numbers, if it is 0, 0, the sum should be 0 and carry should be 0. If it is 0 and 1, the sum should be 1 and carry should be 0. If again it is 1 and 0, again the sum should be 1 and carry should be 0. If A and B are both are 1, then you can see that the output carry should be equal to 1 and the sum should be equal to 0. Okay, so that is 0, 1 and 2. Okay, so this is what we want to represent over here. So how we are going to implement is what we are going to discuss. Okay, so let us go into the detail of designing of half adder circuit. So first I will give you a small introduction of binary adder. What is a binary adder? So as you all know, addition is the basic arithmetic operation which we perform in all the digital circuits. So addition is the basic, okay, it is a very basic arithmetic operation. Okay, so the circuit which performs the addition of two binary numbers, okay, addition of two binary numbers is called as the binary adder. So this is a fundamental block of any digital circuit. So the circuit that performs addition of two binary numbers is called as the binary adder. So here you know that binary adder, okay, again here we are classifying into two types, okay. So there are a lot of applications of the binary adder. For example, if you take normal calculator or your cell phone, so wherever you use the addition, because you know all the computers and your cell phones are all digital circuits, because they can understand only zeros and ones, that is, it can only understand the binary numbers. It cannot understand any 1, 2 or 3, okay, it can only understand zeros and ones, okay, combination of zeros and ones. So we need a adder in order to execute the arithmetic operation, okay. So how we are going to design it is what this video is all about, okay. So binary adder, there are two types. One is called as a half adder, the other one is called as a full adder. So what do you mean by half adder? So half adder is nothing but it is going to perform addition of 2 bits, okay. So it is going to add 2 bits. So for example, if I give you can see that the input is A comma B. So A can be 0 and B can be 1, or both can be 0, and A can be 1 and B can be 0 or something like that. So it can be any input. So the output should be or both can be 1. Okay, so the output will be observed as S comma C. S is nothing but the sum and C is nothing but the carry. Okay. Similarly, in case of full adder, so what is the difference between this half adder and full adder is nothing but, see, in case of full adder, it is nothing but addition of 3 bits, whereas half adder only performs the addition of 2 bits, whereas in case of full adder it performs the addition of 3 bits. The third bit is called as the carry in actually. So carry in, for example, if there is a carry, so that can be input, okay, and based on that the output can be varied. So similarly, the output you are having carry out. So input you are having 3 input is there, that is carry in, and output you are having the sum and carry out, okay. So output is similar to half adder, whereas input we are having 3 different inputs. So this is what all about the difference between the half adder and full adder. So hope you are clear with the definition, okay. So now going on further, let us discuss about in detail about the half adder, and next video we will discuss about the full adder in detail, okay. So first now in this slide, I just want to emphasize that half adder and full adder, the difference between half adder and full adder is, in case of half adder, the number of input is 2. In case of full adder, the number of input is 3. That is, half adder is used to perform the 2-bit addition, whereas full adder is used to perform the 3-bit addition. That's what you want to understand. Okay. So now moving on. So what is half adder? So half adder is a combination circuit. So what do you mean by combinational circuit? So combinational circuit is nothing but, so we have gates. So gates are called as a, so we design this half adder using the gates, AND gate, XOR gate, NOT gate, all those. So those things are called as a combination circuit. So combination circuit is nothing but a combinational circuit. So half adder is designed using the combination circuit, which is nothing but AND gate, OR gate, or XOR gate, or something like that. Okay. So here it is going to add two different binary numbers. Okay, instead of adding two numbers, here we are going to perform the addition of two different binary numbers. Okay, so we will go to the truth table. So what is the truth table of half adder? So let us go into the truth table. So you can see that the truth table of half adder. So you are having two inputs are there. So A and B are there, and two outputs are there. C and S is there. Okay. So if A is 0 and B is 0, you can see that sum is 0. If A is 0 and B is 1, you can see that sum is 1. Is it right? So it is an OR. So it is we are performing the OR operation. So if A is 0 and B is 1, your output should be 1. If A is 1 and B is 0, you can see that the sum should be again equal to 1. But if I put 1 and 1, if both are 1, then it should be equal to 1 and 0, because it will be having a carry. Okay, so it will be having a carry. So this carry should be 1, whereas sum should be equal to 0. So this is what the expected output in the two pins of the half adder. Okay, so half adder is having 4 pins totally. In that 2 input pins are there, that is A and B, and 2 output pins are there, that is C and S. So how we can design it is what the discussion is all about. So this is the truth table, please understand it. Okay. So now you can see that this in the resultant sum. So this is your resultant sum. So this output is called as resultant sum. In that you will see that that sum is nothing but the least significant bit, and carry is nothing but the most significant bit. So sum is called as the least significant bit because it is in the rightmost side, and carry is called as the most significant bit. Okay, so this is you just know all about that. Okay, so first you can see that first 3 combinations. So let us analyze this truth table. Okay, first for the, that is in the first 3 combinations of input, you can see that carry will be equal to 0. So in the first 3, you can see that if it is 0 0, also the carry is equal to 0. If the 0 1 1, the carry is equal to 1. If the 0 1 and 0, again the carry is equal to 0. So in the first 3 input types, okay, you can see that the carry is equal to 0. Whereas in the fourth case, you can see that, and whereas the carry is equal to 0. Whereas in fourth combination of the input, in case of the fourth combination of input only, this carry will be equal to 1. And similarly, in the first 3 combinations, you can see that what about this sum? The sum can be 0 or 1. Is it right? So it can be 0 or 1. Okay, can be 0 or 1. Whereas in case of the fourth combination, you can see that the resultant sum will be equal to 2, and because of which sum should be equal to 0. So from this, how do you understand? So you can see that this carry, it is something like an AND gate. Is it right? So 0 0 is 0, 0 1 is 0, 1 0 is 0, again 1 1 is 1. So it is something looking like an AND gate. Is it right? So the carry can be implemented easily by using the AND gate. But how this sum looks like, it is nothing but an XOR gate. Is it right? So it is a toggle gate. So if it is 0 0, the output should be 0. If 0 1, the output should be equal to 1. If 1 and 0, the output should be equal to 1. If both are 1, if both are 0, then the output should be 0. So this particular thing can be executed by means of the XOR gate. Please understand. Okay. So from this we can understand that sum is nothing but an XOR gate, whereas C is, that is carry, is nothing but an AND gate. Please understand. Okay. So this is what finally we come to a conclusion. So how we can draw it now? So you can see that. So this is how it looks like finally, the half adder. So I am getting A and B I am giving. Okay, so I am giving to the XOR gate. So since the sum output truth table is something looking like XOR, so sum equal to XOR. So I am getting the XOR gate over here. Again A and B I am going to give to the AND gate. So carry is nothing but A dot B. So so here I am using the AND gate to get the carry output, whereas I am using the XOR gate to get the sum output. So this is how this half adder circuit, which is the basic element of all the arithmetic operations, has been designed. Hope you are clear. Okay, and I'm sure I have given a detailed explanation of how to design the half adder using the gates. Okay, so the half adder is nothing but it is having a combination of XOR gate and AND gate. So you can see that a half adder is nothing but it is having the combination of XOR gate. So in order to produce sum, you're using the XOR gate. In order to produce carry, you're using the AND gate. Okay, so a half adder is nothing but it is a combination of XOR gate and AND gate. Please understand. So thank you very much, and I'm really very happy to share my knowledge with you all. And if you really like this video, please give a thumbs up to this video. And if you have any doubts, also please comment to this below. As well, if you feel that this particular video will be helpful to someone, please share it. And if you really like the videos which I post in this channel, please subscribe to my channel and give some support to this channel. Thank you.